The last part of this section doesn't have a video for it. It's just in terminology. So buck up. We got a story. Sarah sells Girl Scout cookies to people in her neighborhood. Afterwards, she decides to ask everyone and her customers if they were satisfied with their service. The next year, she sells again, but now only asks the people who live on her side of the street what they thought about her service. Well, their service. Whatever service. All right, so simple story, not much to it, but we can pull out some terms from this little story. These terms are just for FYI. You'll see them much more in detail in stats. These are demonstrative purposes only. Here they come. First off, her customers in total would be considered the population. That is the collection of all possible outcomes, responses, measurements, or counts that are points of interest. She does not care about anyone she did not sell cookies to. So those people would be outside of the population. She only cares about the people she sold cookies to. Now, the second year, I got excited. I skipped ahead. By giving a survey of whether or not they liked the service, she was trying to measure the response. And the response is actually a variable. So you might see on some surveys, how satisfied were you 1 through 10? So putting the number down is trying to measure that number, and the number value you actually pick would be the variable. The problem with that is that actually it's not a problem. If you have a number, that's better. But if you said good, bad, okay, everyone has different concepts of good, bad, and okay. Numbers are probably better to work with because everyone can think of the worst experience they've had and the best experience they've had, and they can say it from a 1 to a 10 there. So a number is a better idea there. Now, by asking everyone the first year, she conducted what was called a census. When you ask absolutely everyone, you get a census. That is the absolute most accurate way to gauge any of your questions that you might have about service in this example. However, just like in the US, a census takes a very long time. That's why we only do it like every 10 to 20 years. It's better, or easier, I should say, to conduct what is called a sample when you only ask a portion of the population. However, if your sample does not represent the population, you got a problem. We'll talk about that on the next slide. The results of the survey are called data. Actually, it's on this slide. The results of the survey are called data, and the collection of all that data is called a data set. So right there, as it says, a bias is a flaw in the sampling process, and that occurs when the sample does not represent the population. So remember, she talked to people on both sides of the street the first year, and she only talked to the people on her side of the street the second year. Well, if there were, making this up, 20 people who lived across the street from her, and there were 2 people that lived on her side of the street, do you think that those 2 people represent all 22 customers? Hopefully you said no. There is a mathematical way to determine how many you need in a sample so that the sample is a better gauge of the population. But hopefully you do agree that 2 is definitely not close enough to that value. So her sample would have been a bias or introduced a bias into her results, and that would be bad. So when your sample does not reflect your population, you got yourselves a problem. That's not good. You need to start over, pick a different sample, or again, ask everyone for a census. All right, I think that is 2.4. Let's look that up. It's a black screen. I broke it. All right, that's it for 2.4.